Hello ladies and gentlemen, welcome to the video notes for Chapter 8, Section 6, Part 2, which covers the law of cosines. Now, in the previous two videos, we've covered how to use the law of sines. Now, that is only usable for us when we know two angles and one side. Now, again, I have really simplified law of sines because this is aimed at a freshman in high school who is in honors mathematics. So the question arises, well, what if you don't know two angles? What if you only know one angle? So what if you know side angle side, or two sides and a non-included angle? Or what if you don't know any angles, side, side, side information? If that's what you know, you've got to have another rule that allows you to continue to work with those triangles. That rule is known as the law of cosines. The law of cosines is very similar to the law of sines in that it is a relationship based on the idea of cosine for the abstract triangle ABC. So if triangle ABC has side lengths little a, little b, little c, as shown. Now again, that's the same thing we've been talking about, where angle A and little a are opposites. Angle B and little b are opposites. Angle C and little c, okay, the opposite side is the same letter but in lowercase. The law of sines is actually the same for all three sides of a triangle. I'm going to say it in words as I write down the first version, and that is that any side length squared, so let's say A squared, is equal to the sum of the other two sides, sum of the squares of the other two sides, B squared plus C squared, minus 2 times the product of those two sides and the cosine of their included angle. Now what we need to notice is that the law of cosines contains only one angle measure, in this case angle A, and that little a, the side length opposite that, is by itself. This could just as easily be written for either of the other two sides. What I'm saying is little b squared is equal to little a squared plus little c squared minus 2 times a times little c times the cosine of angle B. Again, if the equation contains angle B, then little b is the side length that is by itself. Finally, if I wrote it for side length C, c squared is equal to a squared plus b squared, that looks strangely familiar, minus 2 times a times b times the cosine of angle C. Nope, I'm going to do that in yellow. Let's get all the colors right here. Okay. So again, angle C and side length C. Side length C is by itself because the formula contains angle C. It will be used anytime we are given three sides and no angles, and anytime that we are given two side lengths and one angle. Now again, this is aimed at a freshman in high school in honors geometry. It's not that simple when you get a little bit higher, okay? But that's how we are going to tell the difference. Now, one thing we need to notice here is that that third version, this one right here, that looks a lot like the Pythagorean theorem. And that's because the Pythagorean theorem is actually a special case of the law of cosines. If C is a 90-degree angle, then that last part, negative 2 times a times b times the cosine of 90 degrees, is 0, and that equation becomes the Pythagorean theorem. So just something to keep in mind, that this is a more general rule that works for all triangles, whereas the Pythagorean theorem requires that 90-degree angle, because otherwise you'd have to subtract 2ab cosine of that angle. All right, so on to the next slide then. So here is the easy mode version. These do require a calculator. So what we do is we look to see, well, what angle do we know? In this case, we know angle C, which means little c, the side opposite angle C, should be by itself. So when we're writing our equation, we're going to say little c squared is little a squared plus little b squared minus 2 times a times b times the cosine of the angle we know, which is angle C. Again, it's important to realize that whatever angle we know, we have to put in the equation, which means the side length opposite that will be by itself. So when we plug in these numbers, what we're looking at is x squared equals 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 28 degrees. Now, there are no variables on the right side of that equation, which means it can be fed directly to the calculator. Again, be very careful as you're typing that in. The big mistake people make is they hit the negative symbol instead of the subtraction symbol. That is a subtraction symbol. So as you're typing that in, type it in exactly like it reads. 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 28 degrees. That will give you x squared equals 27.17637,661. I'm not rounding that because in higher math we do not round intermediate steps. Then we need to get x, not x squared. So then we will need to take the square root of both sides. So we take the square root of that wonderful number. And again, you should not need to type that number into your calculator again. Most calculators contain an answer option, which stores the last answer. On the TIs that we use, we would get the square root symbol by putting in second and then hitting the second button. Then the x squared button, which is near the 7. That would give us square root. Then we would hit the second button again, and then we would hit the negative button, which if you look, it says ANS above it, or answer right above it. And then we would hit enter, which takes the square root of that decimal. The square root of that decimal is 5.21. Now in the directions we are told to round to the nearest tenth, so none of the digits after that 1 matter. That 1 is telling us to round our answer down or leave the 2 alone to get 5.2 units for the length of the side marked x. On to the next problem. Again, we look to see, well, what angle do we know? We know angle A, which means little a, which is the side length opposite angle A, is going to be by itself. So little a squared will be little b squared plus little c squared minus 2bc cosine of angle A. Again, whichever angle we know, the opposite side length is by itself. So we're looking at x squared, which I actually would have preferred to be in black. X squared equals 54 squared plus 120 squared minus 2 times 54 times 120 times the cosine of 64 degrees. So 54 squared plus 120 squared minus 2 times 54 times 120 times the cosine of 64 degrees. Type that into your calculator. Be very careful. Take your time. You should get 11,634.70994. And then we take the square root. So we take the square root of that number, second x squared, second negative, to plug in the answer. We get that x is approximately 107.86, meaning we should be rounding our answer to 107.9, and the units are inches. The side length marked x is 107.9 inches approximately. There are a couple more of these, so we're going to do 2 more. Again, if you need to pause the video and get stuff written down, do that. That's the beauty of a video lesson, is it goes at your speed. You can watch it over and over again if you need to. So here's the next one. Again, which angle do we know? We know angle B. So little b, which would be the x, is going to be by itself. So little b squared is little a squared plus little c squared minus 2ac times the cosine of angle B. So that's x squared equals 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 62 degrees. Into the calculator that goes, and it out comes 38.70959248, and square root, and we get 6.22. Again, we're supposed to be rounding to the nearest tenth, so that would be 6.2 centimeters. Now, another place where people tend to run into problems is when it's not A, B, and C. That doesn't matter. It just means we're using different letters. We're still going to make sure that the letter that is opposite the angle that we know, which in this case is angle G, is by itself. So our equation would be little g squared equals little d squared plus little f squared minus 2 times little d times little f times the cosine of angle G. If that bothers you, just change D, G, and F to A, B, and C and use one of the ones in your assignment, but you shouldn't need to. It's the same equation every time. So we're looking at x squared equals 19 squared plus 15 squared minus 2 times 19 times 15 times the cosine of 125 degrees. Into the calculator, we feed that. Again, be very careful as you type that in to make sure that you don't type it in incorrectly. Make sure you close your parentheses. You get x squared is approximately 912.9385,687. And then we take the square root. Second square x squared to get the square root. Second negative to plug in the answer. And we get that x is approximately 30.21, meaning we would round down or leave the 2 alone. And we are not specifically given the units, so we write the generic 30.2 units. Now that's the easiest version of the law of cosines. The next video we'll look at the next hardest version. And then the final video will cover kind of a unique area equation that's kind of cool based on side information. So that's it for this video. Go to the next one if you want to see the next version of law of cosines. Thank you very much.